Hello, everyone. My name is Ioannis. I'm from Kudzu with Dimitris. We are developing the Kudzu Analytics platform. That's like one thing you guys seeing later. I'm also like the author of HEAP35, RF Metadata Analytics. Super excited to be here. It's amazing to be part of like a so awesome community. Regarding this Wisp blog thingy, I mean, I've been following this development since the beginning. Here with Kudzu, we had like a very similar product, like roughly the same idea with Rack, and we have seen this like whole thing like in the hardware level. But the guys at Rack have really done like some pretty good job there. They have like nailed it. This particular kit is really good. Yeah, so that's me, everyone. So excited to be here.
Right. Yeah, it's good to have you, man. And you're going to be presenting about the Kudzu platform here momentarily, right?
Mm-hmm.
Giving us a little insight into what you folks have going with the analytics, right?
Definitely.
Perfect.
I'm going to show you all the little details we have.
Awesome. Hey, it's good to have you, man.
So my network is a bit like damaged here, but I'll try my best and let's see if we manage to pull this off. So
Perfect.
First of all, who of you guys already know roughly what are we doing? Like, have you seen our products? Like, I just want to check like what's the scope, what are you doing? So, okay. First of all, I'm going to start like briefly a bit of a background. So in Kudzu, we're doing two things. So we're like trying to cover like regarding for like in the IoT domain, we want to cover both sides, both the device and the network. So we're kind of worried, we're kind of trying to provide all the services needed by the network operators to install and maintain well efficient and like robust networks, and at the same time make it simple for people to deploy sensors on these networks. We're trying to cover both these two spectrums. Our foundation work before we entered the Helium domain was to use network analytics in the world of LoRa. So as you know, the world of LoRa is quite dynamic. It's not like you are in the 4G world or in the Wi-Fi world where things are pretty robust. You're controlling the frequencies, you know what you're doing. LoRa is pretty versatile, has many corner cases. It's important for you to know what's your payload, where your radio configuration, and this makes it quite unreliable as a network. That's why what we are trying to do is to try to find out means and give tools to network operators so they know what is going wrong and how they can fix their LoRaWAN deployments. So that's the, let's say, day zero of our project, which is like the Kudzu Analytics like platform. So I'm just gonna try to pull in, I'm just gonna try to go on the side. So what you see behind me is the Kudzu Analytics platform. So let me share another side, I'm just gonna, this is like the part that we're talking about the Helium network. Let's try first, simple. So let's start briefly about analytics. So what we are doing, what our platform is doing is you're connecting various different channels, the metadata that are being collected by your hotspots. So metadata is for every packet received, like the signal strength, like the channels used, the frequency used, the spreading factor, all this kind of information. We don't care about the data. We care only about the length of the data. And with all this kind of information, we're feeding into a bunch of like machine learning algorithms, just like simple charting. And we're extracting information about the network, the status, and all this kind of things. Like, for example, behind the scenes here, you see like the network status of our network in Ceros. You can see some like basic stuff like signal strength distribution, like you see here. All right, so here is the, that's like the Kudzu Analytics platform. So as I mentioned here, we have a bunch of networks fitting in here. We have a Things network, we have like a self-deployed system, and we're actually working into getting Helium Analytics also into the system. So we have deployed a bunch of gateways in our region. So I'm also gonna show you quickly like a map, what I'm talking about. So destroying my machine here. So like we were in Syros. Syros is a pretty nice island here in Greece, in the middle of Aegean. It's pretty good in the summer. We have a bunch of, this is like showing you only the Helium deployment that we have like in Syros. We have also the Things network deployment, and we have also like our own like network deployment. So I have a bunch of gateways in the area, right? Out of these gateways, whichever gateways are participating in the system, they're feeding this analytics metadata. So for people concerned about the traffic, there is a local processing in the device, so you can collect a bunch of data, summarize them, and send the summary in our service every once in a while, because we don't want to duplicate the stream of the data. And by collecting all this information for every packet received, the signal strength, and all this information, we're able now to reconstruct the status of your network. For example, here you see that like most of our packets is like on the spreading factor 100, like the peak is here 110 to 105, which means it's like a, decently spaced device, like devices from the gateways. And you see we're using spreading factor 9 to 7, much more than spreading 10, like 11 or 12, which is like a good balanced network, let's say. You can see also like the signal noise distribution is pretty normal. And then you see something like this, for example. This is something quite famous we've seen like in our network. Of course, not all of the devices are good LoRa citizens, for example, LoRa 1 citizens. They're actually abusing the bands, they're doing problems. And this is like one of the problems with the LoRa 1 band, like, right, you cannot control this. Like you can have all this kind of like things getting wild in your network. And here, for example, you can see that someone is like using the 3 standard channels, like which is like the default, like unregulated, uncontrolled like frequencies, but they're not properly using the entire band. This is like one big problem. And this is something you can really see in your dashboard right away. And you will know that if you're doing an application development in the area, these channels are going to be noisy. So you might want to consider different strategies or different approaches to what you're deploying here. The system is doing some kind of analysis on its own. So for example, this thing found some devices sending a lot of data with a pretty bad signal quality. Like this means that if you have ADR enabled, what happens is that the ADR will try to change spreading factor to get into like a better position, but 56 bytes is too much and will be capped, so it won't be able to be accounted for the next spreading factor. If it goes like, for example, to spreading factor 12, you're gonna lose this packet. It's like a warning, it's like a notice. So all these little intricate details about the protocol, we're analyzing and we're presenting it to you. That's like the main idea, like behind the scenes. So likewise, like channel saturation, downlink page sizes, everything that we can collect out of the system, we're getting them and presenting into a nice, like user-friendly manner. And like in addition to that, we collect like anything that we can, like from these devices. We're just like charting them here, like in this kind of view. So for example, you have like a heat map of your network, like downlinks, uplinks, all this kind of traffic, all this kind of analysis, what's happening in the area. Like, for example, I mean, if you're a network operator, you need to know about bursts and where things are getting wild in your network. So we're trying to find all this kind of situations, all this kind of problems. Again, trying to give all the tools we can for someone that has a network with like sensors and everything and want to guarantee the day to deployment from this point onwards. Like another cool feature we're doing here is we are trying to find out if your area is well covered. For example, here's like a big, like 1,000 like feet view of what's your network situation, how critical is your network. In this sense, for example, it says that one of your gateways here is serving a 21% unique segment of your network, which means that your network is only seen by one gateway. This means that if this gateway goes down, you're going to lose 21% of your network. As a network operator, you don't want to do that. You actually want to spread your devices further and further, and being able to cover like all this kind of environment, this kind of situation. So this is like very few of the problems that we're trying to solve. And another amazing feature is that since we're collecting signal strength and we know the position of the gateway, we can even position all this information on the map, and then we can do a pretty like rough estimation using only signal strength. We don't need any kind of GPS information to classify areas. So we can say that, this area is pretty well covered, this area is bad, because these positions that we have collected on the map, we know that they're better or bad in these kind of areas. Now, this is the introduction like to what we have been doing as Kudzu all these years, and we're now bringing this in the world of Helium. So this was like one of the reasons that we proposed the HIP 35. It's like a proposal that can bring the power of this analytics into the world of Helium. How we make it possible is up to debate. Like this HIP35 proposes one idea of how these things can be fed into a system like this, or a home cooked system like on your own. And I just wanted to show you how powerful these things can be, like what kind of information you can extract out of this kind of systems. So apart from analytics, so as I mentioned, Kudzu want to have successful network operators, successful people deploying networks. And for this domain, in this particular aspect, we also provided a planning tool for Helium. So with one of the things we found like on the market, like which is missing, is being able to fine tune and position your device the best way possible without too many extra costs when deploying, when doing your planning, for example. And then we realized that there are different kind of ways you can, different ways you can actually do your calculations. Like one very, very famous thing is to use with CloudRF or this kind of planning tools that every time you have to pay, for example, for simulation. So we decided to move the simulation away from the server side and try to bring it on the client side. So the Kudzu Analytics platform has enabled this kind of real-time analysis to be happening in your browser. So you don't have to be limited by how many analyses you can run. You're actually free to run as many analyses as you like. So I'm gonna increase a bit the size. Actually, let me switch the window and focus directly on this window so you can see a bit more, like in higher analysis, resolution, what I'm seeing here. So I'm going to do some kind of like a planning process. If you're a user, you don't have all this clutter of all this new gateway. So you can start by putting one gateway into just drop a marker. So you can drop this marker here. And what you can do right away is you can enable coverage analysis. The moment you enable coverage analysis, the system is gonna perform like a point-to-point like visibility analysis from your from the place you dropped it to the environment, the surroundings. So you see here, we're gonna download the elevation information. That's it. So this is real time. So I just like drag it in another place, and it kind of gives you this view. What you see here, let me just move this aside. This is the signal strength, for example, real-time estimation of the signal strength from this point towards any other points on the map. And you don't need to wait, you don't need to pay per render. You just like drag it around, and every time you drag it somewhere, you have this radio frequency estimations. This is radio frequency estimations, including Fresnel zone obstruction, which means that we're trying to give you the most pessimistic approach. For example, the black pixels here means that this is visible. You can actually reach that point, but the Fresnel zone is obstructed by more than 30%, meaning that you're going to have a big reflection. You're going to have an overall degraded network performance. But you don't need to worry about that. As a user, you just care if you want to analyze your visibility or your coverage, you can just like enable this, and you can add more and more devices. Let me enable a few more of these devices that I have in view here. And you can see how well the network that you have deployed covers your area. But that's only one of the things that you can do with the platform. Like, of course, when you're doing your planning, the coverage is not enough. You also want to make sure that you're well seen by other gateways, and how well you can, let me open like a few more here and toggle this one too. And so the next thing you would like to do is you'd like to see how many other gateways, where's going to be the place where you're going to put your gateway so you can maximize the number of different gateways you can see. And this is the intervisibility analysis. This is another kind of analysis we're supporting, which is again landscape based. But what it does, it actually, for every pixel on the map, it performs like a line of sight calculation for all the gateways enabled. And it finds out at which points on the map you're seeing most of the gateways out of the ones you've enabled here. For example, here on the view, it says you that, hey, blue means you have one gateway visible, light blue means like two gateways, and we want to go somewhere on these yellow ones. And I see some yellow ones down here. If I move now my pin here, my gateway down to these yellow lines, it means that here I'm seeing at least 3 other gateways. So the moment I put it here, I can immediately say that, hey, this is the place where I can put my gateway so I can maximize the number of different gateways I'm actually seeing. And there's there's a bunch of other things that you can do. Like let's go a bit more on the Helium specifics. We're also doing some analysis regarding your reward scale, because it's important to find out places where you can put your device so you can maximize your reward scale. What happens, of course, if you have too many devices in a closed space, then it's actually going to degrade your reward scale into a lower value. Let me try to enable all of these devices within this radius of like 5 kilometers. So I can see all these kind of things and have something like a more realistic scenario. So you can present this analysis on whatever resolution level you like. So you can start by a bit higher, and let's go a bit deeper. Deeper. And for example, you see by moving your gateway in any place, you real time affect the scale. You see here just like dropped immediately on 0.5, and you can use this kind of real time estimation to try to position your device or to like fix this device so it doesn't affect your entire network. You see in real time how everything changes around you. So you see how you're affecting your neighbors, how you can actually damaging the situation. And this is how you can plan about your network. Now you're seeing here with blue pins, all the gateways already contributed to the system, to the Kudzu platform. But of course, that might not be always there, because if you're going to some new area, you want to see which devices do you have in the area. And we're also fetching Helium gateways live out of the Helium platform, the Helium API. So you can actually ask, sorry, not this one, this one. So you can ask to bring in the nearby Helium hotspot. So even if you're in the area without Helium hotspots, you can actually ask the API to bring in the actual hotspots that are in this area. You can also find out coverage by other networks. We have also like the Things network gateways you can bring like nearby, so you can find out what's happening in the situation. You can also see like what were the real witnesses of your Helium hotspot. This works only if you have configured your gateway as a Helium hotspot, aka given your hotspot address, so it can be properly identified, and other kind of features like in the hotspot domain, in the Helium domain, sorry. And one of the other powerful features that we're offering here regarding the reward scale, more specifically, is that if you have already deployed a network, you might have already been damaging yourself regarding like the reward scale. So it's important to find out what are the best strategic moves you can take so you can optimize your overall network. For this reason, we have a heuristical system that tries to perform mutations around your network, trying to suggest you, for example, the best moves you can take so you can optimize the overall quality of the reward scale of your particular network. For example, here, I mean, it's a random. So it's based simulation based, so you can actually keep shuffling until you find something which is good regarding your solution. But it tries to minimize the number of moves and then minimize the number of distance, the overall distance you can take for your network. So it says, for example, here you need to take this and move it in either of these, like the position of the circle. Then you need to take this and move it somewhere in this place here. This and move it somewhere here, and this and move it somewhere here, for example. And this, by doing this kind of moves, eventually you will bring your reward scale back to like everything once, for example, things like this. This is like an example of like a bit of like too much noise in this case, but the idea is that there's like you can just like keep running until you find a good solution. As I mentioned, this is just like the surface. So we're actually, this was like the MVP, let's say, project of us. We're planning a bunch of new features on the upcoming weeks. We're first of all redesigning the whole platform to make it more user-friendly. This was very friendly for engineers, network operators, that they know a bit more about these things. We're actually trying to educate people and teach them how to use this kind of platforms in a much nicer and more friendly interface. And as I mentioned before, we're also trying to get the analytics out of Helium into the system, so we can offer this kind of information in a whole new level, of all this kind of analytics and information. As I mentioned, the overall goal in this approach is to try to make everyone a really good network operator, because practically now, by owning a hotspot gateway and contributing to this network, you're being yourself a network operator, like a part of a bigger system, a part of a bigger network. And what's most important, that delivering good quality to your network. This was my introduction. I hope it was not too long, and I hope that you could follow up with this kind of like train of thought that I had. If there's any questions, please let me know.
No, that was very well said. And I like what you say, that as you know, operating a gateway, you are a network operator. And you know, that's what we all want to do, is maximize our coverage that we're providing on the network. So yeah, if you don't mind taking a quick Q&A, if anyone has questions, you know, please, now's the time. Please jump in here.
Sure. Any question?
So hey, this is Mike Duchesne. How is this such that like developers like us on this call, can we use this now? Is it set up for something like that, or not yet?
It's already online, so you can actually jump in and start using it. If you're talking about the analytics part you can use right now if you're using a Semtech compatible like path somewhere in your like Semtech packet forwarder compliance system. With HIP35, once applied, we will be able to actually use this information out of the network without any modification in your existing stack. That's like the goal we want to go. So if you're using if you have like a DIY hotspot, or if you have like a light hotspot, but you have disconnected your concentrator from your miner, then you can tap into this channel that sends this information, and you can extract the metadata. But with HIP35 is what we're actually trying to not having to do this anymore, to actually extract this information in the elegant way possible. That's about analytics. Planning, you can already use it. So I'm gonna post this link here.
And so
on the chat.
So let's say I have I don't, but let's say I had a do-it-yourself hotspot so I could separate it and use it now. And let's say I have a problem in my network where for some reason I'm getting a large packet loss somewhere between the sensor and the Helium network. Would this tool help me figure out where that loss is coming from and what the root cause is? How?
Yes, you can.
Talk to me about
the idea would be the following. So in this kind of scenario, I'm expecting you have more than one gateways receiving this particular packet, right? So having a dense enough network, you can extract this kind of information from there. You can, I mean, we're collecting latency information and other kind of metadata from the packets themselves. So we could, for example, find out that there is some lag and some latency in the exchange between the server and the device itself. But the most important information for your case is to actually check if the rest of the gateways are receiving that packet in timely fashion, or if it's being dropped by this gateway. So using the packet data that were received, even encrypted, just getting the checksum of the data, you can deduplicate them across these devices. You can find out which gateway is losing that packet. So you can see, for example, that by the analysis, I can see that this gateway is within range, but it's constantly losing packets. And this is how you can identify that this gateway is having some kind of trouble by communicating with this node, for example. And these are queries you can actually place in the system already. It's not something like out of the question.
Okay, thank you. Very cool.
You're welcome.
So if I wanted to use, for example, I got one off the shelf for Nebra, for example, like after HIP 35, how would someone go about using the analytics? Would they need to do something to switch that on, or? Yes. So since this is gonna include some additional traffic, then it's an opt-in feature. So you need to enable it on demand. So we're in discussion with various manufacturers. So one choice is that it's going to be on the UI, an option which says, hey, enable analytics and forward them to this domain. And then you can point out to our collector so it can receive this data, or you can set up your own analytics domain. So we don't want to vendor lock this. It's actually a feature enabled for everyone.
So if you want to enable this, you need to go to your hotspots or to whatever is managing your hotspots, and then enable per hotspot this feature that will forward this analytics information into this platform.
Awesome. I've also got a DIY hotspot. How would I go about getting the documentation to set up
so I can give you
analytics?
I can give you a link, and it will be actually quite interesting. If you want, we can pair at some point and help you like in more detail if you find any problem. Let me find it. So if you're running Linux in your machine, or like any level, it needs to be Linux. We have a micro, like a man in the middle. There's like a little utility you run locally in the device, and then you point it. The packet forwarder goes into this man in the middle, and then this man in the middle forwards the data where the packet forwarder is supposed to go. And then it creates like a split channel with the analytics that sends it to our server. So there's some guidelines. You need to get the key, put the key, set up the environment variable, start it. And this is how you can enable collecting this kind of analytics the next moment. So you actually start getting this data almost immediately.
Awesome.
Where did the name Kudzu come from?
So Kudzu is actually a Japanese bush, which is known for its aggressive extension, and so it's actually it's how the network gets expanded and covers the entire area. So the same way this bush goes and covers the entire like world.
Okay. Oh,
It's a bit semantic, and it doesn't die.
I was curious on going off that name. I saw an article that somebody, it was a kid who's into botany, and he actually inserted helium into the roots of a kudzu plant in order to try and kill it. I don't know. I wasn't sure if that was coincidence, if that came from the name, but if you Google it, there's an article.
That's actually interesting. I need to research that.
Yeah.
Nice.